Hi, I'm John Donahue from the Institute for Quantum Computing, and today we are going to measure the width of our hair using laser light. Light is an electromagnetic wave. Just like water waves, when light encounters a small object, the waves bend around it. We call this process diffraction. When those waves meet again, if they meet in phase with each other, we'll see constructive interference. If they meet out of phase, they'll cancel each other out through a process called destructive interference. By looking at the pattern of interference far away from the object, we can learn things about the object, for example, its size. The reason we don't see this in our everyday life is that it's only apparent when the object is roughly the same size as the wavelength of the light, which is less than a millionth of a meter for visible light. However, when we have an object that is on that scale, for example, a human hair, we can see this effect very clearly, and today we're going to use that to measure the width of our hair. For this experiment, we'll need a laser pointer, a measuring tape, scissors, a calculator, and a ruler. Once we have our hair, the first thing we're going to do is tape it across the laser pointer so that the laser pointer illuminates the hair. Now that we have our hair taped on our laser pointer, we need to create a long, clear path to a flat wall, at least a few meters. Use your measuring tape to measure the exact distance. Shine the laser onto the wall and notice the pattern appearing of constructive and destructive interference. Have a friend either trace out the pattern or measure the distance between the dark spots. We'll also need to know the wavelength of our laser pointer, which should be around 532 nanometers for green and around 650 nanometers for red light. Now we'll take that value along with the distance between the laser pointer and the wall, as well as the separation between the dark spots, and use that to calculate the width of our hair in centimeters, using this equation here. Most human hairs are between 1/10 and 1/100th of a millimeter wide, way too small to measure with a ruler. However, using techniques like this, where we look at the diffraction pattern far, far away from the object, we can measure these incredibly small objects. This same technique can be used to measure things like the size of blood cells, as well as to understand the crystal properties of many materials. We can see similar interference effects with photons, electrons, even atoms and molecules. These kinds of interference are essential for many quantum information-enabled technologies, including quantum computing and quantum sensors.